Okay, let's do this problem with energy. Our spring constant is 5 newtons per meter. Our mass is 80 grams. It's 0.08 kilograms. We're going to give the amplitude of motion is 14 centimeters, which is going to be 0.41 meters. What's the total energy of the system? So we know that the total energy can be expressed as the energy it has stored in potential energy when it's at its maximum amplitude. So this would be 1/2 times the K, which is 5.14 squared. That's the amplitude, is the 14 centimeters. And this is 4.9 times 10 to the minus 2 joules. In part B, we're asked the maximum velocity of the mass. This happens when all the energy is kinetic. So we want to set the total energy equal to 1/2 mv squared and solve for V. And that gives us a velocity of 1.1 meters per second. And finally, we want to find the speed when it's 7 centimeters from the equilibrium position. So this is more involved because we have to look at the total energy as being partly kinetic and potential, adding up to the total energy of the system. I can get rid of the half terms, and V squared can be written as K over M, A squared minus X squared. To find V, we take the square root of all that. And we get a speed of 0.96 meters per second. It's slower than this was, which was its maximum, so that makes sense. Pretty happy with this. Not bad.